R to S. So it says that we're going to subtract the x coordinates. So let's look at R and S. How far is it from -1 to 4? Along a number line. How far is it on the number line from -1 to a +4? 5 units, yep. So we would have 5 squared. You can subtract them. -1 minus 4 is -5, but we're talking about distance, so it doesn't really make sense. And plus, if you square a negative, you're going to get a positive anyway. Then we're going to subtract the y. So how far is it from -3 to a +4? 7. And you can count it over here on your graph as well. If you count from R to S, so you would count, let's see, 1, 2, 3, 4, 5 to the right. And then you would count from here up, 1, 2, 4, 5, 6, 7. So that's where those numbers come from. And then we do the arithmetic. So 25 plus 49. So 74, the square root of 74. And you can get the decimal equivalent if you want to, but we're not really after what the length of the sides are. We just want to make a comparison and see if any of the other ones are the same or if they're different. So let me write that on there. This is the square root of 74. And then we're going to do the next group here. Let's do from S to T this time. So we're going to subtract the x's or think about how far the x's are apart. So we're going to go from 4 to 8. How far apart are those on a number line? 4. If you're not sure, you can always count over. And then the y coordinates, we're going to subtract them or figure out how far apart they are. So 4 and -1. They're 5 units. So I did 4 minus -1. That's where I got 5 from. Okay? Square each number. So 16 plus 5 squared is 5 times 5. And 41, square root of 41. So those two lengths are not the same. And then we have to go one more time. We have to find R to T. Erase some of the scratches up here. So from R to T, all right, so we want to subtract our x's. So how far apart is -1 and 8 along a number line? 9, good. So this would be 9 squared plus, then we look at the y coordinates. -3 and -1 are how far apart on the number line. So 2 squared. We get the square root of 85. And then we want to look at all three of them, make a comparison, and decide if the triangle is scalene, isosceles, or equilateral. Are two sides the same? No. Is all three sides the same? No. So scalene. So this is a scalene triangle. So I'm doing this subtraction here in my head so it doesn't look nearly as intimidating. Or you can count on your graph. All right, we're going to do one more example. All right, so go ahead and graph and plot your 3 points and draw your triangle. The E first. How far away is 3 to -5? 8 units, good. And if we look at the Y coordinates, how far from 9 to 3? So count on your graph if you're not sure. 6. So when I say count, you can count from E to D. If you go 1, 2, 3, 4, 5, 6, 7, 8. So there's the 8. And then if you go up 1, 2, 3, 4, 5, 6, there's the 6. So 64 plus 36. What is that? Oh, that's a 9. So 100. So the square root of 100 is actually 10. It comes out nice and even. All right, now I want you to find the other two with your partner. Find the other two lengths, and then go ahead and see if you can classify it. I'll give you a couple of minutes to. Did you get the square root of 50 for each one?
Yeah.
For the other two? So what type of triangle is it if now we have two that are the same? Isosceles. This is an isosceles triangle. Two sides are the same. Okay. Now if all three were the same answer, then it would be an equilateral triangle, right? Dustin brought up the point about you could tell whether or not it was a right triangle. It's possible this one could be a right triangle. If that was right in here was at F, if that was a 90-degree angle, we would have to look at the slopes and see if their slopes were opposite reciprocals. If you had some patty paper. Oh, you did it like kind of visually? Mm-hmm. Okay. Yeah, so if I move it all one, the E would now be down here. F would be, where would F be? Here? And then rotating it. Oh, I see. Mm-hmm. And then we rotate D. Okay. So you're kind of doing that patty paper in your head? Yeah, that would absolutely work. Now, if you were going to justify it, though, you'd have to show the slopes. Okay? You could count the slopes. This would go down 1, and then 1, 2, 3, 4, 5, 6, 7. So this would have a slope of -1/7. This would have a slope, let's see, rise would be 1, 2, 3, 4, 5, 6, 7 over 1. So their slopes are, in fact, opposite reciprocal. So we could even go even further for this one and say a right isosceles triangle. Now that's kind of going a little above and beyond. But nonetheless, you could absolutely do that. Little extension. Okay. We're going to do some practice in class today. Okay, thank you.